One of the Mimikatz functionality is impersonating a high privilege user on the domain by taking advantage of the SeImpersonatePrivilege. In this video, we're going to explain how to do it from scratch instead of being a script kiddie and just executing an already existed tool. Let's do it. As always, we have to take a moment to explain fundamentals before writing any line of code. In the last video, we have demonstrated how to dump the LSAS process memory, and we have said that the LSAS responsibility is to verify our credentials when we attempt to log into our account. If our credentials are correct, we get an access token that represents me as a user in the system and what privileges I have. If you are still confused about this concept, please watch the first video of this series for more detailed explanation. In this video, we're going to cover the token impersonation. But before we get into this, we need to talk about access token types. Well, there are two types of access tokens. A primary access token, which is the one we have talked about. So when you are successfully logged into your user account, a primary access token is set to you, and a copy of it is set to the process you run on the system. But sometimes, a thread in the process you run need to access resources that are only accessible by other users. Let me give you an example. Imagine that you have an mssql service in your domain, and this mssql service runs under a user called sqlsvc. Now I am the user Hisham. I have successfully logged into my account and a primary access token is set to me. Now, me as the user Hisham, I have a file called database.backpack in my desktop, which is an msql database file, and I want to import it to the msql app. Well, obviously, I will go to the msql app, import the file, and there you go, we've got the database from the database.backpack file. But wait a minute, the database.backpack file is owned by me, which means the SQLSVC user don't have the privileges to read it. You are absolutely right. The SQLSVC don't have the primary access token of the Hisham user, but it have an impersonation access token that impersonate me to read the file and import it to its database. Now this impersonation access token is only set to a thread, not to the whole process, which means a thread in the msSQL process have the impersonation access token. So what happens is that when the msSQL process wants to read the database.backpack file owned by the user Hisham, a thread from the process took a copy of my primary access token, impersonate me, read the file and import it to its database. And that's the second access token type, the impersonation token. But keep in mind, the impersonation token is related to a thread, which means it didn't affect the msSQL process. The msSQL process still got its primary access token that have received from the SQLSVC user. Makes sense? Great. Now, if somehow I was able to authenticate and compromise the SQLSVC user, whether it's through an SQL injection or elevating my privileges to that user from a low privilege user, I can impersonate other users. Why? Because the SQLSVC user has the SeImpersonatePrivilege, which means he can extract access tokens from other processes and then impersonate them. And that's exactly what we're going to do in this video. So this is the lab where we're going to perform our exploit. I have logged in as the user SQLSVC. If I run who I am SQLSVC. Let's run who I am priv. As you can see, that user have SeImpersonatePrivilege, which means, for example, I can choose a process that runs under the admin user, take its access token, and create another process with the same access token. And this process can be a reverse shell, CMD, PowerShell, whatever you like, and then executing commands as that user we have impersonate, the administrator in our case. By the way, that may not make sense for you now, but I promise that you will get it when we start coding. In the last video, our code was a mess, so I organized it a bit, defined the classes at the header file, and the implementation at the C++ file. So as you can see here, in dump_lsas.h header file, I defined the class and the functions we have explained in the last video. And then in the dump_lsas.cpp file, I defined the implementation of those functions that we did together. And I call those functions here in the main, so I basically check if there is another argument passed while executing our app. It checks if it's LSAS, then it will execute the code we have done before for dumping LSAS. If it's not LSAS, then it will check if it's the token impersonate argument, which is what we're going to do in this video. By the way, you will find the GitHub repository of this project in the description below. As always, let's split our goal into smaller tasks. So I have successfully gained access to the domain as the SQLSVC user. This user have SeImpersonatePrivilege, and our goal is to elevate our privileges from this user to be a local administrator in the system by taking advantage of the SeImpersonatePrivileges that we have. So the first things we have to do is checking if we have the SeImpersonate privileges, because if we don't, we will not be able to perform this attack. So let's do it. So let's create a new file, call it tokenImpersonate. Then in the header file, let's declare the first function that we're going to create. It's going to return a boolean, and let's call it hasImpersonatePrivilege. Now let's go to the tokenImpersonate.cpp file and then start the implementation of this function. So the first things we need to do is take a look at the current process access token, which is the code we are writing, because it has a copy of the user sqlsvc access token. That's why we're going to read it and check for the SeImpersonate privilege. So let's first declare a handle that's going to contain the current process access token. Then we're going to use the open process token Windows API function that's going to get for us the access token of a specific process. We need to pass the process we want to get the access token from, and that's the current process, the code we are writing now. That's why we're going to use the getCurrentProcess Windows API function that's going to return the current process as a handle. The second parameter is the desired access, what we want to do to that process access token. In our case, we just want to read it, query the access token, so we can see the privileges we have. That's why we're going to use the token query parameter. The last parameter is where we want to save the access token we get from our process, and that's of course the current process access token handle. If that's not working as intended, then we will print a message saying that we have failed to open the process token and return false. But if the function successfully got the current process access token, then we will need to declare a variable called LUID with the LUID type struct. That's basically going to contain the LUID of the SeImpersonate privilege, because every privilege or object have an LUID, a local unique identifier. So to be able to check for a privilege in an access token, we need to know its LUID. Make sense? Great. Now, to get the LUID of a privilege, we're going to use a Windows API function called lookup_privilege_value. And this function will basically get the LUID of a privilege just by specifying its name. We're going to set the first parameter to 0, which means we are looking only in the local system. The second parameter is the privilege name, which is the SeImpersonate privilege. As you can see, this is a symbolic constant that represents the name of the impersonation privilege. If this function failed, we're going to print a message saying that we have failed while getting the SeImpersonate privilege's LUID, then return 0. If that works correctly, we will need to declare a privilege set struct that will contain a set of privileges that we want to check its existence in the current process access token. The first attribute is the privilege count, which is the number of privileges we want to look for. We're going to set it to 1 because we are only looking for the existence of one privilege, which is the SeImpersonate privilege. Then the next attribute is control, and we're going to set it to privilege set all necessary. Indicate that all specified privilege must be enabled for this function to consider the check as successful. If any of the privileges are disabled, the check will fail. So basically, the privilege we are looking for in the access token must be enabled. Then we need to specify the LUID of the privilege, which is the LUID I've got from the lookup privilege value. Then we specify that the SeImpersonate privileges have to be enabled by setting the attribute to SePrivilege enabled. Then let's declare a boolean called result that's gonna tell us if the SeImpersonate privilege is set to the current process access token or not. Now we're going to use the privilege check Windows API function to check for the privileges in the access token. The first parameter is the current process access token. The second parameter is the privileges we are looking for, which is the privilege set. And then the last parameter will be the result. That's going to be the return value of the privilege check function. That's going to be true or false, based on what the function have found. Again, if this function failed, print a message saying that we have failed checking for the privilege, and then close the current process access token handle. Then return false. And at the end, if everything works as it should be, we will close the handle and return the result. Let's test this function. So basically go to the main function, create an object with type tokenImpersonate, then use the hasImpersonatePrivilege function. So if this function returns true, then we print that we have the SeImpersonate privilege. Else, we print that we don't have the SeImpersonate privilege and return 0. Let's compile our code, run it as the user I have logged in with, which is Hisham. As you can see, we don't have the SeImpersonate privilege. Now let's run this exploit against the lab where I have logged in as the sqlsvc user. I will need to run a Python server where the solution is located. So python-m http.server, then go to the lab where we're going to test this exploit. Then get the exploit using wget, the IP address, the port number, and amashow.exe, which is our exploit. Now let's run it. So amashow.exe, hit enter. As you can see, we got a message saying that we need to specify the parameter, which is the token impersonate. Let's do it and hit enter. We have the SeImpersonatePrivilege, so it's working. That's great. Now, the next task is to enumerate all processes running on the system and then check for their owners. Then if we find a process owned by the administrator, we take its access token so we can impersonate that process. Let's do it. So let's go to the token impersonateH and create a function called enumerate process. And this function will return a list of processes founded in the system. Now, the type of this list is process info, and process info is a struct that represents the information of a process. Let's declare it here in the top. So type def to create an alias, and then the struct keyword, because as we said before, the process info is a struct, then underscore process info. Open the curly braces, and by the way, this underscore used here is common in C++, just to indicate that the name, which is the process info, is intended for internal or private use, and it's useful to distinguish between public and private names in code. Then we will declare the attributes of this structure. The first one is the process ID, then the SID of the owner of the process, then the domain username, then the name of the process, then the domain username length, set it to 0, and name process length, set it to 02. And then aliases names of the struct will be process info and a pointer called pprocessinfo. So basically the struct defines the process info. As you can see, its attribute here, we have the process ID, the SID of the owner of the process, and from that SID we will get the name of the process owner, and then the domain username and the name of the process and the length of the domain username. And we will see the benefits of declaring this structure later. Now let's jump to our C++ file and start the enumerate processes function. So we're going to create a list of process info struct called running processes. That's going to be the return value at the end. So basically this running processes struct will contain all running processes in the system. And then a handle that's going to be a snapshot of all the running processes. We're going to call it current process snapshot equal to create tool help32 snapshot Windows API function. Pass to it th32cs snap process, indicating that we want a snapshot of running processes, because this function can also get us a snapshot of threads and modules. Then the next parameter is the identifier of the process for which we want to create a snapshot. And we're going to set it to null to indicate that we want a snapshot of all running processes in the system. If you want to create a snapshot of a specific process, you will need to specify the PID of that process in the third parameter. I'm going to create a process entry 32 called process holder, which is the variable that's going to contain the process we got from the snapshot. Set its size to the size of process entry 32. Then we will need to use the process 32 first Windows API function to retrieve the first process from the current process snapshot and put it in the process holder variable. If there is an error, then we will say that we couldn't list running processes, close the current snapshot and exit. But if that works, then let's declare a pprocess pointer called process equal to new process info, and this variable basically going to contain the information of that process holder. So process equal to getProcessinfo, and we pass to it the process holder. Now let's create this function called getProcessinfo that takes a process as a parameter and then return its information in a processinfo struct. Let's go a little bit here in the top, create the getProcessinfo function that returns the pprocessinfo and then the parameter, which is a process with type process entry 32. And then create a pprocessinfo pointer called process equal to new processinfo, and then a handle called process h and process token h that we will see their utility in the next line of code. Now we will set the process PID to th32 process ID attribute of the process entry 32 pointer. Now we have the PID saved and we need the name of the process. First of all, we need to get the length of the process name so we can allocate memory for the process name. And we know that the name of the process is always just the executable file name, and that's why we're going to use the sgxe file attribute of the process entry pointer. And we're going to use the string cch_length function, which is a string handling function that's going to take the process entry 32 sgxe file attribute as the first parameter, which is the executable file name of the process, and then 260, which is the maximum number of characters to consider when determining the length of the string. And the last parameter is the name process length, which is a pointer to a variable that will receive the length of the string. And then we're going to allocate memory for the name process. So process name process equal to new wchar process name process length, which is the length of the process name. And then +1 to allocate an extra character for the null termination character at the end of the string. Now what we need to do is basically copy the name of the process to the name process attribute using string cch copy function. I'm sure you understand what we did here. Now we have the process ID, we have the process name. What we need now is the process owner. Well, getting the process owner is a bit tricky. There's not a direct way to do it like a Windows API function that we just pass the process and it returns the owner of it. But because you guys understand how things works, I am sure that you will find a way to get the owner of the process. So please pause the video. I'm going to give you a second to think of how to get the process owner, okay? Are you done? Let me know your answer in the comments below. So we know that each process have a copy of the user access token, and this access token, as we said before, holds information about the owner and other security attributes. So basically, we're going to take a look at the process primary access token, get its owner, and then save it in the process owner attribute. Makes sense? Great. Let's do it. So we're going to set the process H that we have declared before to the Open Process Windows API function, and we want to get information from that process. So the first parameter will be process query information. Then we set the second parameter to false to indicate that the handle to the process should not be inheritable by the child process. Because when a new process is created, it has the ability to inherit handles from the parent process. This inherit handle allows the new process to access the same resources or objects that were opened in the parent processes. But some handles may represent sensitive resources that should not be accessible by the child processes. And that's what we did. We specify false, so the child processes will not inherit handles of the current processes. And let me give you a quick example of the inheritance in this case. So let's say I have opened CMD. Now CMD is a process. It has a copy of the user primary access token. From CMD, I can open other processes like notepad. Now this process notepad inherits the access token from the CMD process. And if CMD allow handles inheritance, the notepad will inherit CMD handles because notepad is a child process of CMD, which is the parent process. Makes sense? Good. Let's get back to code. Now, if the process handle is equal to null, that means we didn't open the process. So we need to deallocate the memory we have reserved for the process variable. So we're going to create a function here in the top called deallocate process info memory that takes a process with type process info struct, and then we're going to set the process ID to null. And then if the domain user name length not equal to 0, that means that a memory location is allocated. So we need to deallocate it or free it using the delete operator, because the memory was allocated with the new operator here in the getProcessinfo function. And we do the same thing to the name process length. Let's get back to our getProcessinfo function and use the deallocate processinfo function and return the process at the end. But if everything works fine, then we open the process token using the Open Process Token Windows API function. We passed away the process handle, the desired access, which is the query informations, and where we want to save this token, which is the process token H. If that's not working, then just return the process. If that works as intended, then we're going to create a double word variable called process token owner size, which is the size of the process token owner, and then a pointer to the process token owner. Now we're going to use the get token information Windows API function. The first parameter is the process token handle, from where we want to get the informations. The second parameter is the information we want to get, which is the token owner. The third parameter is a pointer to a buffer that receives the requested token informations. In our case, we will set it to null because we're gonna determine the required size of the buffer later. The third parameter is the required size of the previous parameter. Since the previous parameter is null, the third parameter is the required size. Since the previous parameter is null, we will set this parameter to 0 because we said that we want to determine the size ourselves. The last parameter is process token owner size, so by passing null as the buffer pointer and 0 as the buffer size, the function will return the required size in the process token owner size variable. And this allows us to allocate an appropriately sized buffer to retrieve the token owner information. Now we need to allocate memory for the process token owner pointer, so let's pass this line and start explaining. So what we basically did here is allocate memory from the heap to store the token owner information. You need to know that when a process is created in Windows, a portion of memory in the heap is created for that specific process. So what we did here is basically allocate a portion in the heap from the global portion of the current process That's why we specify the get process heap, which is basically going to get the current process equal
heap.
to ND. And then the second parameter is heap 0 memory flag that indicates that this person is going to be initialized with zeros. And then the last parameter is process token owner size to indicate the size of the person we want to allocate in the heap process of the current process. Let me visualize this for you to have a better understanding. So this is the app we are creating, which is a process. Now this process, when it gets created, it allocates a person in the heap on memory. What we want to do is allocating a person from that heap for the process token owner. And we use the heap alloc function. We specify the current process. Then the second parameter is basically fulfilling the memory allocated for the process token owner with zeros. And the last parameter is the size of that person, which is the token owner size. Makes sense? Great. Now we're going to use the getTokenInformation function again to get the token owner. But the difference here now is we're going to specify the process token owner pointer instead of null and process token owner size instead of 0. If that returns false, then we're going to close all handles that we have opened, then free the heap using the heap free function, and then we're going to deallocate the process we have allocate memory for using the deallocate function that we have created before. And then return process. Then we're going to set the process SID owner pointer to the owner attribute from the process token owner pointer. Then free the heap of the process token owner pointer using the heap free function. Now we have just got the SID of the process owner. We need to convert this SID to a readable name. And this readable name will be the owner name and the domain name. So let's declare a double word variable called owner name buffer size and domain name buffer size. Assign them to 0. Those variables basically will contain the size of the domain name and the owner name. Then a variable called SID type, which basically going to contain the type of the SID. It could be a group, a user, or any other object. Then declare the username and the domain and assign to them null. Then we're going to use the lookup account SID Windows API function to get the owner and the domain name. The first parameter is null to indicate that we want to look for the name in the local system. Then the SID, then the username where we want to save the username, and then its size, then the domain and its size. And the last parameter is the SID type. Now this function is expected to fill because the size of the buffers are set to 0. Now because this function fills, its purpose is just to retrieve the owner name size and the domain name size. So we can use them to allocate memory for the username and the domain name. So this function will return false and not of false is true, which means we're going to get into the block inside. What we need to do now is allocating the memory for the username and the domain, and then repeat the same line of code. But now it's not going to fill. In fact, it's going to put the username and the domain in their variables. But if that somehow fails, then close all handles, deallocate the process, and return it. Then we're going to need to create another function called combine user domain name. This function will take the domain and the username. Then we will create a variable that holds their sizes, which are the domain name length and the username length, and the domain username length that's going to hold both of them. Then create a variable called combined user domain name that's going to be the return value. Then we're going to use the string cch length function to calculate the length of the domain. We pass to it the variable we want to calculate its length, which is the domain name, the STRA save max ZCH, which is basically a predefined maximum length number. As you can see, it represents this big scary looking number. Then the third parameter is where we want to save that length. We do the same things for the username. Then the domain username length is the sum of both lengths, +2 for the backslash and the null terminator. Then we will basically allocate the memory for the combined user domain name and use the string cch copy function to copy the domain name to combined user domain name, and then use the string cch cat function to concatenate the backslash with the combined user domain name, and then use the same function to concatenate the username with the combined user domain name. And at the end, return the combined user domain name that contains the username and the domain name. Now let's get back to our getProcessinfo function, and we're going to just set the domain username to the combined user domain name of the domain and the username. Close the handles we have created and return the process. So we are done with the getProcessinfo function, but we are not done yet. We still need to finish the enumerate process function. So we have stopped it in the process equal to getProcessinfo, and we passed to it the process holder. Now this function will return the information that we have seen before about this process, its owner, the SID, and so on. So the only thing we need to do now is just saving those processes in the list of processes. So if process PID not equal to null, running processes, which is a list of processes, and then push back process. And that's just the first process. We need to run a while loop through all other processes. We're going to use the process to return next Windows API function that's going to always jump to the next process after each iteration. We pass to it the current process snapshot and the process holder that's going to contain the process. Then again, do the same thing. Create a process, use the getprocessinfo, and if the PID is not equal to null, push the process to the list. And at the end, we will close the current process snapshot handle and return the running process list. Great. Now let's test our function. Let's go to the main, then create a list of pprocessinfo struct, call it running processes, and assign to it enumerate process function. Then use a for loop, so for process in running processes, cout process name, process domain username, dash dash, and the PID, which is the process PID. Let's run our code, download the app in our lab, and run it. As you can see, it prints the domain name and the username and the PID. Now we know which one to impersonate. For example, this process owned by the administrator. Now I'm gonna add an input to ask the user to input the PID of the process he wants to impersonate. Let's get back to our code, declare a variable called process ID, which is the PID of the process we want to impersonate, and then ask the user to choose a PID from the list of processes shown in the terminal. And then we're gonna put the process ID in the process ID variable. Let's run it again. As you can see, it asks us for the PID. Let's, for example, choose this PID, which runs under the administrator. Great. Now, the next function basically going to take that process ID, extract its token, then create a new process with that access token. And that's the impersonation. Let's do it. So we're going to call this function ImpersonateTokenAndSpawnNewProcess. And this function is going to take two parameters. The first one is the PID of the process we want to extract its token to impersonate it. And the second parameter is the process to launch, which is the process we want to launch and execute with the access token we have gathered. So we will create a bunch of handles, the target process handle, the target process token handle, and the new token handle. So the first handle will contain the process that we're gonna get from the PID parameter, the second one will hold its token, and the third one is the process handle of the process we're gonna launch. Now we're gonna declare a startup info object of the startup info type. And basically startup info is a structure that specifies the startup information for a newly created process. For example, one of the known attributes of this struct is the DWX, DWY, DWX size, and DWY size. And those attributes specify the initial position and size of the new window created for the process. And that's why we need to use the struct to be able to control the process creation and presentation. The next thing we need to create is the process information object of type process information struct. We're going to use this struct to get details about newly created process information and its associated thread. One of the members of this struct is each thread, and this member is a handle to the primary thread of the newly created process. Now we're going to zero the memory of the startup info and the process info using the zero memory function. We specify the memory address where this function will start putting zeros and the size to know where it's going to stop. And then we will need to set the CB attribute of the startup info object to size of startup info struct, and CB basically specify the size of the startup info variable. Now, we're going to get the target process handle using the open process Windows API function. So target process H equal to open process. The first parameter is the desired access. We just want to query information, just get the process info. The second parameter is true to indicate that the handles can be inherited by the child process. Then the PID of the process we want to open. If that still returns null, then we will display a message saying that we failed to get the target process handle and return -1. If not, then we're going to keep going and extract the token from the process using the open process token function. We're going to specify the token duplicate flag to duplicate that process token and save it in the target process token handle. And that's what we want to have, a copy of the token. If it's still null, then close the handles and return -1. Now we're going to use the duplicate token EX that's going to basically create a new token by duplicating an existing token. The first parameter is the target process token, which is the token we want to duplicate. Then the next parameter is the desired access to that token, which is token all access, to indicate that the new token will have full access. The next parameter, we're going to set it to null to indicate that we want default security attributes of that access token to be used. The next parameter is the level of the impersonation that the new token should have, which is the security impersonation. Because if you take a look at the msdn documentation of the levels of impersonation, we have 4 levels. The security anonymous level, the server cannot impersonate or identify the clients. That's mean if we set the level to this one, we will not be able to impersonate. The next level is security identification and the security impersonation and security delegation. Those last 2 are the most interesting ones for us because with them we can impersonate the client security context. Then the next parameter is the type of the token, which is a primary access token, because we want to spawn a new process, and as we said before, primary access token is set to the process. That's why we're going to specify the primary token parameter. Then the last parameter is the handle that's going to hold this new primary access token, which is the new token handle. If that didn't work, then we're going to print a message to say that we have failed duplicating the token, close the handles and return -1. Then we're going to create a process creation flags variable assigned to it, create new console, bitewise or, and create new process group. Now what we have done here basically is that our process will have its own console, and then the second flag indicating that we want a new group for that process. And a process group is a collection of processes that can be controlled as a single unit. But in our case, we want a new one for that process, a new group for it. So now we're going to use the create process with token Windows API function that's going to take the new token as the first parameter and set the second parameter to the logon with profile to indicate that the system should load the user profile when creating the new process. And loading the user profile involves initializing environment variables, user-specific settings, and other user-related resources. Then the third parameter is the name of the application of the process. We're going to set it to null because we want the process to have the name of the process we're going to launch. The next parameter is the process to launch, which is the parameter of this function. And then the process creation flag that we have created. The next parameter, we're going to set it to null to indicate that this new process will have the same environment variables that the current process who launched this process have. Then the next parameter will set it to null too, and this parameter specifies the working directory of the new process. Since we have set it to null, that means this new process will use the same current directory of the calling process. Then we're going to specify the startup info and process information objects to get the info of the process. If that's failed, we're going to display a message saying that we have failed to create a new process. Close all handles and return -1. If that works as expected, then we're going to return the process information to DW process ID, which basically going to return the process ID of the new created process. Now let's go to the main function and create a wchar t pointer called process to launch equal to cmd.xe. So the process we're going to launch is cmd with admin privileges. Then we're going to declare a non-constant process to launch, and then we're going to use ImpersonateTokenAndSpawnNewProcess function, pass to it the process ID that we submit from the terminal and the process to launch, compile it. Let's run our program, choose this PID that runs under the administrator user, hit enter. As you can see, a new Windows pop-up. Who I am, NT Authority System. Great.